Hi, it's Mrs. Murdock, and today I'm going to talk about negative feedback pathways. So when you have a system, a metabolic system, or a hormone pathway system in the body where you're turning on some final response, what you want is you want to be able to regulate it. You always want to be able to have the option to turn something off after you have turned it on. And negative feedback pathways are built into the body's every chemical pathway. Usually ends with the final response or final molecule in the pathway feeding back to turn off the original one, which is how, when you turn something on, you can then turn it off. So let me illustrate that just simply. So for example, if you have very often, the hormone pathways that we'll talk about begin with the hypothalamus, right? Which is an organ in the brain that's like a great meter measuring device in the brain that's constantly keeping track of your body temperature and your amount of salt, amount of water, amount of hormone levels of all kinds, and then sending signals out depending on if something out of balance. So the hypothalamus will send out maybe molecule A to the pituitary gland, which is the master endocrine gland, which is also in the brain. Okay, and maybe the pituitary gland then sends out molecule B, and molecule B will activate some target gland in the body. There's lots of endocrine glands in the body, and the pituitary gland might send molecule B to that gland, and that will release molecule C, and then molecule C is affecting the final response. But molecule C also has the added role of when it builds up enough, molecule C will feed back, negatively feed back, very often on both the hypothalamus and the pituitary gland. Right? So this is negative feedback of the final step in a hormonal or metabolic pathway to turn off the original message. So this gets turned off, and no more of this is made once it reaches a certain threshold. So if you now illustrate that with a more concrete example, for example, this is a basic feedback pathway, which is one of the most common pathways that hormones follow in the body. Now let's make it more specific with something we did just recently, which was the story of testosterone in the male body and what happens to it if you take a synthetic hormone like trenbolone. So again, we're starting with the hypothalamus. We start with the hypothalamus, which is often the organ in the body that detects an imbalance first. It sends a gonadotropin releasing hormone. Right? If it senses that testosterone is too low and it's needed in the body, the first signal sent to the pituitary gland is gonadotropin releasing hormone. The pituitary gland then has two hormones that are triggered from this releasing hormone, two of them. One of them is called luteinizing hormone, and the other is called FSH, follicle stimulating hormone. And these will go to trigger in a male body, will go to the testes, which are the organs of the human male, which then will be stimulated to produce testosterone. Testosterone, which is a steroid hormone that has many, many effects in terms of human male secondary sex characteristics, increasing muscle mass. So they have an effect on muscle cells, they have an effect on bone density and bone strength. They have some effects on other things, aggression levels and such. That's the final. that's the final response, is to trigger the testosterone. And when it reaches a certain threshold, it naturally feeds back to both the pituitary and the hypothalamus and has a negative effect, turning off the gonadotropin hormone, the FSH, and the LH once there is enough testosterone to affect the correct response in the human male body, right? So if you turn something on, you need to have a way to turn it off. It's not good to have too much of anything, and too much testosterone could also be harmful. All right, so that's the basic pathway. That's the normal pathway in the human male in terms of producing testosterone as the final response. Now, what I didn't include here, if I go back and I erase the negative effects just for a moment. Okay, so here it is back. What I didn't include here is that there are extra effects along the way. These hormones here are actually not just for stimulating the testes to make testosterone. They have their own side jobs, which are incredibly important. The luteinizing hormone in a male maintains Leydig cells in the testes, right? Those are the things that are responsible for making sperm. Very important hormone. Even though it's an intermediary messenger along the way, it has its own job, as well as, stimulating the testes to make testosterone. They also stimulate cells within the testes to maintain size and to keep making sperm. Follicle stimulating hormone in a male maintains nurse cells or Sertoli cells, also within the testicles, which are very important for making sure that sperm make it all the way to maturity, get their tails on straight, and have the right size, and have the acrosome enzymes on their heads. All those things are helped by the nurse cells. So a man's ability to reproduce successfully really depends on not just testosterone, right, which maintains his higher body strength and bone strength, but also on the intermediary effects of these in-between hormones, which make sure that the sperm gets made and the testes stay the right size, and the nurse cells are nurturing the sperm, and that's very, very important for his reproductive success. So now enter synthetic hormone. So trenbolone, is a synthetic hormone that looks a lot like testosterone. It's very, very similar. If you look at them, the molecules, you almost can't tell them apart. They're so similar. So this is a synthetic steroid, right? A man-made synthetic steroid, which you take externally, pills, injections, I'm not sure what, but you take artificially, right? And it goes into the bloodstream. It goes into the bloodstream and bypasses, right? It's going to have an immediate effect. It's going to have an effect on this. It's going to give an athlete or bodybuilder the muscle mass that they want. In fact, 3 times more effective for developing muscle mass and bone strength and everything you would want as an athlete. You're going to get it with trenbolone. So it goes straight to that, right? But it totally bypasses the normal pathway here. And in fact, since it's so similar to testosterone, it is able to negatively feed back on the hypothalamus and the pituitary without these intermediary hormones ever being activated at all. So it bypasses all this, which maybe wouldn't be a problem for some hormone pathways, but for this one, these guys, if they're not synthesized at all, because trenbolone goes directly to its final response, and turns the pituitary and hypothalamus intermediary hormones off before they even get started, right? So trenbolone results in luteinizing hormone and FSH never being synthesized. If you're on it for long enough, that's the final effect, because it's inhibiting these. It's there to inhibit those things, and you are constantly re-dosing yourself with it, right? Instead of your body making it as testosterone naturally runs out, right? Which is what would naturally happen. And instead, what's happening is your body never gets to make the true testosterone because it's receiving trenbolone, the chemical signal, directly. So what happens is the Leydig cells are not maintained, the testicles shrink, and sperm production decreases. Nurse cells are also not maintained, so whatever sperm are produced are not being shepherded to their final productivity. So that's how a normal hormone pathway with normal negative feedback systems is affected by taking an outside hormone that bypasses the normal pathway and also bypasses important intermediary hormones, which really are supposed to be there and have their own separate jobs. That's why people who take anabolic steroids, and both men and women take anabolic steroids, this can be the effects. There can be side effects because the intermediary hormones that are supposed to do things along the way before you even get to the final effects are negatively fed back upon, and their effects are terminated. So in men, you're going to have testicle shrinkage, you're going to have sperm production decrease. In women, if you bypass certain important hormonal pathways, a woman might lose her ability to menstruate, might lose her ability to ovulate. So her reproductive capabilities would also go down, even though, again, muscle mass and whatever you took the drug for would increase. So that is the story of negative feedback pathway, and in particular with the pathway that produces testosterone and how it can be interfered with a synthetic steroid. And I hope that was helpful.